Okay, good afternoon, everyone. Thanks for joining the Groundback Lunch series hosted by the Teachers Thematic Group with the title of, very interesting title, Mothers, Teachers, Peers, and the Gender Gap in Early Math Achievement. And we are delighted to have Dr. Robert Shadi from the IDB. He's a Principal Economic Advisor at the IDB, and I just discovered that he was a YP at the World Bank in 1998. Were you the same year?
I think so.
2 years before.
Oh, okay.
Yeah, you're old.
Anyways, after 11 years at the World Bank with Mark and Derek and so forth, he's moved on to IDB. Our big loss, big gain for IDB, I guess. And Norbert's main research area includes ECD, teachers' quality, cash transfer, and also the economic impact on human capital. And he has a PhD from Yale or
Princeton, undergrad from Yale.
PhD and undergrad at Yale. And he also taught at Georgetown and also Keystone. So without any further ado,
Thank you. So, you should feel free to interrupt with questions. If I see that I'm really running behind on time, then I might take the questions at the end. But in particular, clarification questions are very welcome. And I should say this is joint work with Pedro Carneiro, who can't be here because he's presenting basically the same paper right now at a conference at Georgetown, and Yanu Cruz Aguayo, sitting here. And I should also say that this is a labor of many years of research assistants' work, and no less than 5 of the people who've worked on this over the years as research assistants are in this room. So I want to say Nicola Dinen, who's now with you guys here at the World Bank, did a lot of work on this. And then we have here people who are still currently at the IDB. We have Nicolás Fuertes, and we have Alejandra Campos, Minji Kang, and Rafael Hernandez. So this is really, as you will see, it is not a one-off paper. It's something that reflects many years of continued work. And this is just one of the papers that we have from this particular research project. So just to briefly outline what I'm going to be talking about, what we do is we study math test scores for children in kindergarten through 3rd grade in Ecuador. And I just made the same presentation at the Society of Labor Economists annual meeting on last Saturday. So I want to be very careful which parts of this are descriptive and which parts we are confident are causal estimates. And you'll also find that many of the references are to U.S. work, in part because I was presenting it there, and people there are more familiar with U.S. work. But I just want to be clear about that. The first part of the paper is descriptive. We think the descriptives are quite interesting, and they may have a causal interpretation, but we're certainly not hanging our coats on them being causal. Basically what we do is we analyze the associations between various household characteristics, parental education, wealth, marital arrangements, and the gender gap in math, and I'll show you a little bit on the gender gap obviously in a minute. And the second part of the paper provides causal estimates of how the quality of classrooms, teachers, and peers affects the relative achievement of boys and girls in math. So just in terms of what people have written about in this literature before, girls have been found to have lower math achievement than boys in many contexts. The richest evidence, the largest number of papers with the largest number of samples comes from the US, especially for high school and college. And one example here is that the average score of girls on the math component of the SAT has been 30 to 40 points below that of boys. Is now and has been like that for about 50 years. Since they started taking the SAT, girls have had about 30 to 40 points below boys, and that really hasn't changed. And 30 to 40 points in the SAT is equivalent to 0.3 to 0.4 standard deviations, which is not trivial. It's a fairly large amount. And there's some evidence also for younger children. So in this case, for example, Roland Fryer and Steve Levitt have a paper that they wrote around the time, shortly after Larry Summers made the comments that Larry Summers made as president of Harvard, which resulted in, well, we all know what it resulted in. And so a number of papers were written that were trying to clarify what exactly is it that the data show about this. And one of these papers was by Roland Fryer and Steve Levitt, and they show that by 3rd grade, girls in the US lag behind boys by about 0.2 standard deviation. And if you look around the world, this is not everywhere and not in every data set, but you find this more often than not. You find that girls lag behind boys in terms of math achievement. You do not find that in general in language, for example, where boys generally lag behind girls in terms of language achievement. Okay. Now, one thing that people don't realize is that underlying this, this overall effect, this overall difference, this overall gap, there are really actually lots of things going on. The first is that girls lag behind boys in particular kinds of math tasks. In particular, actually, in math tasks that require visual spatial abilities. And we can talk more about that, and I'll show you a little bit on this, but it's not, so these 30 to 40 points in the SAT, in fact, you can eliminate that advantage altogether if you statistically remove questions that rely on visual spatial ability, which is kind of an interesting thing. So girls lag behind overall, but they lag behind because they lag behind very much in a particular set of tasks. The other thing is that insofar as girls lag behind, the biggest gaps are found on the way right tail of the distribution. Not just the top 5th percentile, but people who have done, for example, analysis of the top 0.01 percentile of the distribution, like this paper, show that if you look, for example, at the American mathematics competition, for every boy who's in the top very far right of the distribution, for every girl, there are 10 boys. So there are huge gaps, in particular, in the very right tail of the distribution. This is just, again, this is just descriptive. This is what the data show, not my data in this case. It's just a sort of a statement of what the data show. I'm not yet making any statements that should be particularly incendiary. So insofar as girls lag behind boys, the obvious question is, why is this so? And I say insofar as, because, like I said, they lag behind in some tasks. They seem to lag behind more by some tests than by other tests. And so, but insofar as it's there, the question is, what's going on? Why do we see this fairly large gap? And there is, as you can imagine, a very large number of papers. But probably the richest literature on this is in the psychology literature rather than the economics literature. But there are papers in the economics literature as well. So some have argued for the importance of hormonal differences or differences in brain structure between men and women. I'm not taking any sides in this debate, but there's a rich debate on this. There's a review paper by Sue Halpern and co-authors. If anybody writes to me, it's actually in the paper. But I can send it to you, which they review all of the literature on this. So, for example, there are all kinds of crazy things. So, for example, when girls who are going to have a sex change undergo hormonal treatment to become men prior to the sex change, their math scores go up substantially. It's kind of a crazy thing. There's also, for example, a long literature in psychology which argues that the reason you get these big differences has to do with differences in brain structure that have to do with evolutionary processes as follows. I mean, this is obviously almost impossible to prove or disprove, but the argument goes that basically in tribal societies, and therefore, a long time ago for all of us, men were primarily, rather than women, were primarily in charge of things like hunting large animals, warfare, and so on, and that the argument goes that these require visual spatial abilities, and that therefore there's a natural selection process whereby men were selected on these traits, whereas women, there was no real incentive to select on these traits. Obviously, that's, like I said, how would you ever be able to either prove or disprove that? But there is a literature saying exactly that. Others have focused on environmental influences. And there you can say that either more or different inputs are provided to boys than girls. So again, here there are really interesting findings. So for example, even in the US, even amongst university-educated women, when mothers take their children, university-educated mothers, take their children to a science exhibit, this is a well-known paper, they are 3 times as likely to explain things having to do with hypotheses and how to think about things to boys than girls. These are mothers of university-educated children. University-educated mothers of young children. My goodness, it's easy to get confused here. So clearly, the point is here that the paper by Halpern et al. Is a very interesting paper because it really puts all of these pieces together. And at the end, they don't really come out, obviously, given all of this disparity. It's supposed to be a consensus paper, and this also came out around the time of the Larry Summers comments, where in psychology they tried to write a consensus paper, and clearly there is no clear consensus. It's more along the lines of, look, this is how we weight the relative evidence. Now, even if there is none of this, it is also possible, and this is definitely something that we're going to get into, it's possible that the same inputs are provided to boys and girls, but that boys and girls are differentially responsive to those inputs. Right? So it's certainly plausible, and there's evidence from the US kind of going both ways. So there's a well-known paper by David Otter and co-authors in which he shows that there are larger benefits from school quality for boys than girls. And this finding here fits into a sort of a larger literature which argues that in general, boys in very many different dimensions are more sensitive to the environment than girls. So for example, it is well known, for example, that even all the way going to the womb, male fetuses are much more sensitive to conditions than our female fetuses. So if there's, for example, an economic shock, a woman carrying a male fetus is much more likely to have a miscarriage than a woman carrying a female fetus. So there's, again, all kinds of things that as economists we might not have thought about, but there's a literature on this. But there are other, in terms of school quality inputs, there are also findings on the other side that say, well, actually, no, girls are more responsive to school quality than boys. So basically, it's all over the map. But there is a rich literature on this, which many of you might not be aware of. I certainly wasn't aware of all of it until we got into this research. Okay. In some sense, what I want you to take away from this talk is in part the results on boy-girl differences that I'll show. But really, this is a small piece of a much larger research project. And so I want to tell you a little bit about the research project overall and some of the main findings that have come out of that. So in 2012, we randomly assigned a cohort of almost 14,000 children entering kindergarten, the first year of formal schooling, in 202 schools. We randomly assigned these children. Each of these schools had at least 2 kindergarten classrooms, and we randomly assigned them to classroom A or classroom B. Now, what is exceptional about our project, in addition to the fact that, as I will show you, compliance is around 99%, so that all the children, we said, okay, there's a lottery. The lottery says that these 30 kids in this school go to this classroom, and these 30 kids in this school go to this classroom. In addition to the fact that in 99% of the cases, the kids are actually sitting, the kids we assign to classroom A are in classroom A, and those that we assign to classroom B are in classroom B. So there's essentially almost perfect compliance with experimental design. But in addition to that, what is nobody has done before, and then I'll tell you why this is actually very useful and important, is at the end of kindergarten, we took those same 14,000 kids and randomly reassigned them to first grade classrooms, and then to second grade classrooms, and then to third grade classrooms, and then to fourth grade classrooms, and then to fifth grade classrooms, and we're now in sixth grade, the last year of elementary school. So the important point here is that every year, these children are randomly assigned to a different classroom. So for example, in one year, Keiko and Halsey here might be randomly assigned to, teacher A, Ianu, and teacher B, Norbert. One might go to Ianu, one might go to Norbert. The next year, it's not as if you stay either with the same teacher or separated from Halsey. The next year, you might be together. Because I'm just taking, it's as if I take all of you in the classroom, I do a lottery and say, okay, this half go to that room, and this other half go to this room. And then you do whatever you do, and then at the end of the year, I say, okay, everybody come back in here. Now I do another lottery, this half go to this room, and this half go to the other room. Now why is this remarkable, in addition to the fact that, why is this useful, if you wonder, why does this allow us to do things that truly have never been done before? It is because each child has been exposed to, up till now, 5 exogenous, orthogonal, so unrelated to each other, shocks to classroom, teacher, and peer quality. So if you look at Project STAR, which is arguably the most famous experiment having to do with teacher quality in the US, there was one round of random assignment with somewhat imperfect compliance. So all the kids were assigned to a classroom, and then they stuck with that classroom for grade K, 1, 2, 3, and then they went on with their lives. But you can't extract in any straightforward way from Project STAR whether what matters more is the quality of teacher in K, 1, 2, or 3, because they're all together. There's only one round of random assignment. Similarly, you can't say, does it matter that you had 2 good teachers in a row, because everybody who's with one group of kids is with the same group of kids moving along in classrooms throughout the time. In our case, at least, potentially what you can do is you can say, is it more important to have been assigned to a good or bad teacher in kindergarten or first grade or second grade or third grade and so on? And also, what happens if you get assigned to a good teacher in kindergarten and first grade? Does it somehow reinforce each other? Do we get an even bigger effect if we have 2 good teachers in a row? That's the argument that Jim Heckman makes when he talks about dynamic complementarities. That's what dynamic complementarities is. Others have said, no, actually what we expect is exactly the opposite. That what you'll get is diminishing marginal returns. So what you'll get is a series of good teachers. What will happen is that the total effect should be lower because in some sense you get a big bang for the first good teacher you get ahead of everybody else, then you get another good teacher, and then you get another one, and eventually everybody else is lagging so far behind that they actually begin to catch up even though they didn't get as many good teachers. But there's no way of, at least experimentally, sorting that out unless what you have is, at random, a series of better or worse teachers. Okay. We measure learning at the end of each year. In the first grades, this is something where for 13,500 kids, when you've got kindergartners, you don't just walk in and tell the teacher, here's the test for all the kindergartners, everybody just take the test. So that means 13,500 individual applications of 1.5 hours of testing in 3 sittings. Right? So by the time they're in 4th grade, we actually can go to group testing. But before that, it's a huge effort, as you can imagine. The tests cover language, math, and executive function. We can talk more about the executive function results at some point if people are interested, but I'm not going to talk about the executive function results here, but we have math, language, and executive function at the end of each grade. There's obviously now a growing literature which suggests that early executive function has very long-term payoffs. Executive function, for those of you who don't know much about it, is the capacity to pay attention, the capacity to hold sort of short-term memory, the capacity to hold something in your mind and then apply it to something and then do something with it, and also cognitive flexibility, so the ability to sort of switch from one task to another. And these have been shown, at least longitudinally, to have large effects. So we also have those data, but I'm not going to talk about those unless people ask at the end of the seminar. Okay. Not only that, but we have very rich data on classrooms and teachers. So every year, we filmed teachers teaching for at least 1 full day, and I'll show you little video clips that show you what that looks like. That again, I mean, if you imagine, we now are in year 5 of this thing, or 6, I keep forgetting. So we've got 202 schools, that's 450 classrooms roughly, because most have 2, but a few have 3, 4, 5 classrooms. So let's just take, for argument's sake, 450. That means that by year 5, we've got 2,500 days of classroom actually videoed and coded by this rubric, which is called the Classroom Assessment Scoring System. But in principle, this video could be coded for anything else. I just wondered when I was at the conference in Toronto, at the Labor Economics Conference, one of the people who was there, Phil Oreopoulos, who's a well-known labor economist, said, you know, there's got to be so much in these videos. Why don't you do the following? Take the videos of the teachers who have the highest value added and the lowest value added. Forget about the class for right now. And just bring in 20 people separately. And have them, 20 people who are experts in education, not economists. And have them just look at the video. And have them say, you know what, don't tell them this is the high value added teacher and this is the low value added teacher. But have them look at the video. And have them say, you know, this is what's going on in this classroom. Because we coded it by the class, because there's a literature which suggests that the class, I'll talk more about it, is actually important. But who knows? Maybe it's something else that's going on in the classroom. And certainly, we have the video for somebody to come in and have a look at the video and say, what you really should code them with is this or that. So it's very rich data, obviously. We have standard teacher observables in every grade, so experience, gender, whether they're tenured. And we have, for kindergarten teachers only, we have richer data also on teacher observables. So we have teacher IQ. We actually tested the IQ of all of these teachers. We have the Big 5 personality test. We have teacher inhibitory control, which is one of the dimensions of executive function. We have a lot of other stuff on teachers as well. And then, like I said, we have end-of-grade test scores in math, language, and executive function in every grade. And in math, since I'm going to be talking primarily about math, obviously, this is going to be important. Obviously, the kind of things that you test kids on vary by grade, because kids are supposed to be able to do different things in different grades. So, for example, in math, in kindergarten, it's things like number recognition, sort of little series. So you say 2, 4, 5, 6. What's the number that's missing? They're supposed to say 3. But obviously, by the time you get into third grade, they're supposed to know how to add, subtract, do various things like that. So the tasks that kids get tested on vary, which is kind of crazy. I mean, it's not so crazy in a different setting. I've seen papers presented on India, for example, in which they use essentially the same test throughout, because even by grade 4, many kids can't recognize a single number. Well, that's not the case in our case, in our data. When we basically update the test, it's because essentially by the time you get into first grade, every child can recognize every single digit number. By the time you get in, and so on. So really the test does have to evolve, because otherwise you're testing things that either you're testing things here that are so hard that nobody can do them, or you're testing things here that are so easy that everybody can do them, and it's not a very meaningful test. Okay. Oh, well, that wasn't very good. Okay. And as I said before, there are very high levels of compliance, 98 to 99% in every grade. And this, just by way of comparison, perhaps the most famous study done in the last few years in the US is the Measuring Effective Teaching study funded by the Gates Foundation, in which children were assigned to teachers in the same school, and these are the compliance rates that you get, anything from 27% to 66%. Obviously, we're going to do a lot better when we've got 98, 99% compliance as opposed to 27% compliance. Okay. So, this is Ecuador. This is a slide I probably don't have to show here. I definitely have to show it when I go to the labor economists meeting, because half of them don't know where Ecuador is. But there you go, that's Ecuador. And Ecuador is peculiar. I think it's probably the only country in the world that actually has 2 different school cycles, one for the coast, where about 50% of the population lives, and one for the highlands and the east, where the other 50%. In one case, the school cycle follows the northern calendar, and in the other case, the southern calendar. I have no idea how this originated, and it's not particularly important, but the point is that we had to make a choice whether we were going to do our study with the northern calendar schools or the southern calendar schools, because we had an opportunity to do it at one particular point in time. So we went with those that are on the coast. And these balls over here represent, we took a random sample of all elementary schools that had kindergarten and had at least 2 classrooms. And then the reason these circles are bigger in some places than others is, for example, here, Guayaquil, the second biggest city in the country, there are a lot more schools in Guayaquil that are in our sample than, whatever this is over here, where there's only 1 school, because there are a lot more kids in Guayaquil than elsewhere. Okay, so that's that. So I want to say, what I'm going to do for the next roughly 15 minutes is I'm not going to talk about boys and girls in math at all. I'm going to give you a sense of some of the earlier findings. Because, like I said, I think what's most interesting about this project is just the fact that there's so much you can do with it, and so much, some of which we have done, and so much that we are still doing. So we have a paper in the QJE that came out 2 years ago that focused only on kindergarten, was only looking at kindergarten. It showed that there were classroom effects. Classroom effects is the difference in learning, it's like the difference in value added, the difference in learning outcomes for children in 2 different classrooms. How much does 1 standard deviation increase in classroom quality affect learning? We find about 0.11 standard deviations in both math and language, a little bit lower in executive function. This is very much in line with what is found in the US, 0.10, 0.15, roughly. Classroom effects means that I have assigned kids to this and that classroom. So there are lots of differences between this and that classroom. They're in the same school, so it's certainly not about the school. It's not about the infrastructure. All these classrooms look the same. But in addition to having different teachers, you do have different peers, and you could have some shock that affects one classroom and not another. For example, on the day of the testing, all these kids could have been ill for whatever reason. There was a flu in this class and not in this class, at least hypothetically. And so what we find is that when you look at classroom effects, about 2/3 of them, about 2/3 of the magnitude of the effect is a teacher effect. And how do we know? How can we sort this out? How can we separate it? because for kindergarten classrooms, we actually assign not one, but 2 cohorts of children to the same teachers. So cohort 1, cohort 2. So you can extract from that the part that has a classroom effect that is not the teacher, and the part that is the teacher effect, because you got 2 different cohorts assigned to the same teacher. And so we can work out, statistically, you can work out that about 2/3 of the classroom effect is actually the effect of the teacher as opposed to other things, the peers and whatever else is going on. Basically, much as we've found in much of the literature for a long time now, nothing other than whether a teacher is a rookie, so a teacher who has very low experience, nothing else observable about teachers, about teacher characteristics, as opposed to teacher behavior. I'll show more about that in a second. Nothing about teacher characteristics explains why teacher A is better than teacher B. And that includes a variety of things. It includes IQ, so brighter teachers are no better teachers than less bright teachers, certainly in kindergarten. We also have content knowledge, so the tests that the things that these teachers are supposed to know how to do, whether they know the things the ministry tells them that they're supposed to know, makes no difference in how good a teacher they are. Rookie teachers are worse than other teachers. Nothing else matters. Whether they're tenured or not, doesn't matter. Whether they're men or women, doesn't matter. None of this matters. The only thing that matters, there are large classroom effects, there are large teacher effects, but it's really hard to use any observables to actually say, well, so-and-so is likely to be a better teacher because they're brighter, or they have this or that personality, or they have better executive function. We also know the kind of household they grew up with. I mean, we know everything about these teachers, and none of it explains anything, basically. So really, some teachers, what this says is some teachers are better than others. The differences that I'll show you in a second are large, but our attempts in the literature, all of us, I'm sure we've done so, many of you, I'm sure have done some of the same, to sort of say, well, okay, there must be things about this teacher that makes this teacher better than that other one. It's largely sort of a futile exercise, other than knowing whether a teacher has very little experience. Teachers learn in the first couple of years on the job, and then after that, they don't get any better either. So a teacher who's 20 years of experience, in this data at least, is no better than a teacher who has 15 years of experience, or a teacher who has 10 years of experience. But a teacher who has 2 years of experience is a lot better than a teacher on average who has 0 years of experience, who's like first thrown into the classroom. I was a teacher for 2 years in middle school, and that did not surprise me. Okay. I'll show you more about the class in a second, because that's actually in the other results. Now, here is stuff that is not in that paper, but it is actually important. When Halsey and Dion presented their WDR at the IDB, one of my quibbles with it was that they focus a lot on differences between countries and why it is that this country has a better functioning education system than the other country. And my point is actually that the differences, at least in Latin America, the differences across teachers within schools dwarf the differences across countries. So perhaps it would be ideal if Ecuador becomes Chile, the highest performing country in Latin America in terms of learning outcomes. But it'd be just as good if you just take the somewhat lower performing teachers in Ecuador and turn them into the somewhat higher performing teachers in Ecuador. Even if you didn't change anything else. I'm not saying I know how to turn these teachers. That's not, but my point is that there is, even in a setting in which everything else seems to be failing or not, is whatever it is. Institutions are this or that, and responsibilities are defined like this or like that, and financing works like this or like that, whatever it is. I'm sure all of that could be improved. But even when you abstract from all of that, if you could just take within that setting, take the teachers that are less effective, and I'll explain what I mean by that in a second, and turn them to those that are more effective, the difference that you find is comparable to the difference between Ecuador, which is a country in the middle of the pack, to Chile, which is the highest performing country in Latin America. So my take when I talk to policymakers is, look, it'd be great if you're Chile, it'd be even greater if you're Singapore, but really, let's not worry about turning you to Chile or Singapore. Let's just figure out how you get your somewhat worse teachers to become better teachers. Okay. Well, this is here. What I've divided, what we've done here is for the first 4 years, which is the only data that we fully coded and everything else, because there's so much data coming in that half the time, we're still like 2 years behind in sort of making sure all the data we have is the right data. What we have here is at the end of third grade, in every, let me take a step back. In every school, there are at least 2 teachers. In fact, in almost all the schools, there are 2 teachers in our sample. 2 kindergarten teachers, 2 first grade teachers, 2 second grade teachers, 2 third grade teachers. So in every grade, you could have had either the better of the 2 teachers or the worse of the 2 teachers. So in every grade, in one classroom, there's somewhat more learning than in the other classroom. In some cases, the difference is very big. In some cases, the difference is essentially nil. I'm going to define a good classroom as the classroom of those 2 where there is more learning. Where at the end, controlling for your baseline test scores, children know more. So I'm going to define as a good classroom the classroom with a higher value added. Okay? There was more learning. And the bad classroom as the lower value added classroom. Now I want to be clear about this. I'm not talking like Hanushek about the top 5% of teachers or the I'm just saying above your school average or below your school average. So these are on average, the ones who are on the right are going to be like on the 75th percentile of the distribution, and the ones on the left are going to be on the 25th percentile of the distribution. We're not talking about a sequence of terrible teachers or a sequence of outstanding teachers. We're talking just better than average versus worse than average. So if you're really unlucky, 4 years in a row, you got the worse than average teacher. Every grade, you just were randomly assigned, and it happened to be that you got the worse than average teacher. On average, you will get 2 good teachers and 2 bad teachers defined in this way. But you could have gotten unlucky and gotten 0 or 1. You could have gotten lucky and gotten 3 or 4. These bars are the magnitude of the difference in learning outcomes in math and language for children relative to those who got the slightly or the somewhat worse than average teacher in all 4 grades, those who got the somewhat better than average teachers in 1 grade, 2 grades, 3 grades, or 4 grades. So the 2 things you want to take out of this. The first is that this bar is really big. It's close to half a standard deviation. That is really big. I don't know how many of you actually try to find effects on this and that and the other. Half a standard deviation is very big. And this is not the outstanding teachers. This is just the somewhat better than average teachers. That's the first thing you want to take away from this. So in Ecuador, if you're in the same school and you just happen to get a sequence of the somewhat better teachers, this is how much more learning you have than if you got the somewhat worse teachers. Imagine what this would look like if it was the 95th percentile of teachers. We're not talking about that. The second thing you want to take away from this is that these, and we've tested this, these effects are additive. 2 good teachers is twice as good as 1 good teacher. 3 good teachers is 3 times as good as 1 good teacher. 4 good teachers is 4 times as good as 1 good teacher. There are no dynamic complementarities. It is not as if you get 2 good teachers, the effect is larger than 2 times the effect of 1 good teacher. 2 good teachers is 1 good teacher plus another good teacher. 4 good teachers is 1 plus 1 plus 1 plus 1, or if you want, 2 plus 2. This coefficient here is the same, is twice the magnitude as this one over here, and 4 times the magnitude as this one over here.
Just to understand, when you say good teacher, you're saying a teacher who was good in that year in terms of value added, not
Yes.
one who had necessarily been good in terms of value added the year before. Right.
We only have data on all of the teachers for 1 year. So, right. So what I'm saying is, in kindergarten, in each school, 1 teacher had somewhat higher value added than the other one. And now I'm looking at 4th grade, and okay. So that's what I'm saying. People thinking you can
How
actually
do you
add.
define a good teacher?
What's that?
How do you
The one that has the higher value added. Okay. The second thing is, if you didn't think those were large enough, now you can see, okay, well, let's actually look at where is this effect. So I've just told you that the effect on average of having had 4 good teachers in a row is about just shy of half a standard deviation. Now we're going to run quantile regressions. Quantile regressions look at the effect at different points in the distribution. The effect at the lower percentiles, for example, at the 10th percentile of the distribution, is almost 0.9 standard deviations. This is huge. It is 0.9 standard deviation, and here it's about 0.3 standard deviation. So not only is it really important whether you got the better or the worse teacher, it is particularly important for the bottom of the distribution. So not only are you moving the entire distribution from left to right, you're actually moving it from left to right and squashing the left tail inwards. So it's actually having very large beneficial effects overall, and particularly large beneficial effects in the left side of the distribution. Third, you can look at the magnitude of these classroom effects. Remember, we can't calculate teacher effects. We can only do that for kindergarten. You can look at the magnitude of the classroom effects in different grades. They are largest in kindergarten. In fact, they are about almost 0.3 standard deviations in kindergarten, which is about twice as large as they are in third grade, and with first and second grade somewhere in between. So this part does agree with what Jim Heckman says. Having a better teacher has a larger effect if that better teacher was in kindergarten than in first grade, a larger effect in first than in second grade, and a larger effect in second than in third grade. So if you want to worry about, we want to get better teachers, the first objective should be, at least in this setting, the first objective should be, we want to get better teachers in kindergarten, rather than leave alone high school, which we haven't done, but certainly even within this sort of relatively narrow band. Again, Project STAR couldn't do this, because they're all together. You can't disentangle it. We can say, did it matter more whether you got the better teacher in kindergarten, first grade, second grade, or third grade? One last finding before I actually move on to math. As you will see in my presentation later on, we find that the average quality of your peers has no effect on your own learning outcomes. I'll show you that in a second, so you don't need to worry too much about that right now. But whether your peers, remember, every grade, I'm reshuffling the kids. So even though on average, classroom A and B will have identical peers, that's on average. When you've got 30 kids here and there will always be some differences in the baseline test scores of the kids here. And it wouldn't be the case if you had 1 million kids here or 1 million kids here. When you've got 30, there's always going to be some imbalance, and I'll show you that whether you have somewhat better peers here or here makes no difference to your own learning outcomes. What does make a huge difference, once again, is having some particularly poorly behaved kids who happen to be 90% boys in your classroom. And how do we know this? Again, experimentally. Why do we know it experimentally? Because at the end of each grade, we ask teachers, who were the 5 worst behaved kids in your classroom? Johnny, Jill, whatever. Okay. For those 5 badly behaved kids, which of these things do they do? Did he get angry or frustrated? Does he answer with bad manners? Does he hit classmates? Does he destroy school property? I mean, all kinds of things. Which of these things do they do? And how often do they do them? So we can take the 5 worst behaved kids and basically classify them. There are different ways of doing it as either really badly behaved kids. They do a lot of these things all the time, allegedly every day, to, yes, they're kind of rambunctious and rascally, but, not very often and not very many of these things. Now, the point here is that I ask Halsey, who are your 5 worst behaved kids? And he tells me, the next grade, these 5 kids, as well as Keiko's 5 worst kids, get randomly assigned to the next group of classrooms. So this comes, again, off the random assignment. Halsey says, boy, I had, Rafael over here. It's just crazy. Every day, what he does is he beats other classmates, he tears up their work, he answers, he never sits down. He does all of these things all of the time. Now, the next year, some teacher either gets Rafael or does not get Rafael by virtue of the random assignments. If you've got kids who have a few of these things, it doesn't matter very much. None of these are significant. By the time you get over here, you have kids who, according to the previous grade teacher, do a lot of these things, like 6, 7, 8 or more of these behaviors every day, allegedly. You get huge negative effects on their classmates' learning. So, for example, if you got one kid who the previous teacher reported that in the last year did 8 of these things virtually every day, all the other kids, 37 kids on average in our classrooms, all the other 36 kids learn about 0.15 standard deviations less. That is a really big effect. There aren't very many of these kids. We're talking here, in fact, out of a sample of 13,500, we're talking of about 80 to 100 kids. Well under 1% of the kids. Probably closer to 0.25% of the kids if you really go to the extremes. But those few kids are so badly behaved and disrupt the learning outcomes in the classroom by so much. And you think, well, if there's only 50, well, why are we worrying so much about these 50? This one kid in that classroom is reducing the learning outcomes of his 36 classmates by 0.16 standard deviations. In fact, at any given point in time, even when there's only 50, 60 kids, what you have is that in roughly 1/5 of the classroom in the sample, you got one of these kids. And in fact, if you look at it over time, basically almost all kids in the school have been exposed to at least one of these kids at least one time. So this is non-trivial. You think, oh, it's only 0.025 or 0.25% of the kids in the sample. Why should I worry a lot about it? You should worry a lot about this because these kids have a very substantial negative effect of the learning outcomes of everybody else in the classroom. And everybody is a lot of kids. Okay. So that's all I'm going to say about ongoing research with these data unrelated to this finished paper that I'm now going to talk about. There's a lot more, but I can't put everything in here because you guys will never be able to absorb it all. It's not because, just because there's so much that we're doing with these data. So now let's move on to math performance of girls and boys and try to figure out what's going on there, at least in our data. And I make no grand statements about sort of in the world at large, girls, boys, math. I'm going to show you what our data has, and I'm going to make some claims about what's going on in our data. So in our data, first of all, on average, there's about a 0.15 standard deviation difference in the math performance in K through 3rd grade between boys and girls. Boys perform about 0.15 standard deviations better on the math tests. And if you're all itching to ask me on which part of the math test, just hold your breath. This is the average when you have all of the stuff in the test. What you get is about a 0.15 standard deviation difference. Okay? Is this big? Is this small? One way to place it in context is I'd say it's there. It's not the biggest thing ever. If you compare, for example, the average math performance of children whose mothers have university education with those who have only elementary school education, the difference is about just over 0.5 standard deviations. So you can say that the boy-girl difference is about, give or take, about 1/3 of the difference between children of highly educated mothers and children with basically the lowest levels of education in our sample. We don't have any. In this sample, about 10% of the women have university education. So this is substantially better off, let's say, in an African or Indian context. Right? This is, again, so we know what our population is, roughly. So what we're going to do is we're going to stack the data. What do I mean by stacking the data? And I'll tell you why we use the stack data in a second. What we're going to do is we're going to take all the test scores for kindergarten, all the test scores for 1st grade, 2nd grade, and 3rd grade together. We're going to take them all together. We're going to put all of them, like a stack, as if there were 4 times as many observations as we have. And we're going to run a regression in which we have math learning over here for child I in household H and in school G. This has nothing to do with teachers here. This part has nothing to do with teachers. So there's nothing about teachers here. I'm not going to control for teachers or anything. As a function of that child's age, because that's really important, older children know a lot more math even within the same grade than younger children. And then as a function of whether they're female, whether they're a girl, and whether the mother has secondary school education or university education. So the omitted category is children of mothers with only elementary school education. And I'm also going to include an interaction between children of university-educated mothers and girls. We also tried this with children of secondary school-educated mothers and girls, and we don't find anything there, and this is going to turn out to be important, and I'll show you why. And that's basically it. We're going to do different things with it, and the standard errors in this, because I've got 4 observations for each child, I need to do something about correcting the standard errors, so they're clustered at the child level. Okay, so here's some interesting stuff. Let's look at the first panel first. So when I said before that on average, girls have about 0.15 standard deviations lower test performance than boys. That is this number, 0.14, 0.15. These are different ways of aggregating all of the questions in the test. You can just count the number of correct answers. You can use what's called item response theory, IRT. You can use IRT combined with something else. You can do all kinds of, basically this number here is very similar. It's about 0.14, 0.15 standard deviations. Right here, there's no controls for anything. This top panel is just the average difference between boys and girls, which is about 0.15 standard deviations. But if you look at different parts of the test, you find very large differences. So for example, in word problems, girls do worse than boys by about 0.066 standard deviations. But in this particular set of tasks, which are called number sense, which is, for example, where to put a given number on a number line, what is the missing number in a sequence, things like what's called place value. So you understand that 10 is 10 times larger than 100. And things like that, girls do much worse than boys, and they do much worse than on these other tasks. So the first thing to realize from this is, when the next time somebody shows you a paper that says girls do this much worse than boys or not on a particular test, you should think under there, what is in this test? I mean, there might be nothing wrong. I'm not saying there's anything wrong with this test, but look, nobody would have said, if I have a test that's all word problems is, look, I give you $1, an apple costs 50 cents, an orange costs 25 cents, how many apples and oranges can you buy? That's a perfectly legitimate question to ask. So if you just had a test based on that, you'd have about 0.06 standard deviation, pretty small. If I gave you a test that was all just about basic calculations, so arithmetic, then you'd have about 0.12 standard deviations, which is more like a standard test. And if I gave you a test that was all about these things, about place value and so on, this is kind of like the SAT result. I could have a test that shows very large differences or very small differences. So the next time you see a result, you should think in your head, okay, fair enough, but what are the things that are being tested? Now, of course, what happens is that in most cases you actually don't know. You don't see what is being tested, and certainly if you design your own instrument, you should at least think about these things. Moving down to the second panel, what you find is this. This is going to be our preferred specification, which is item response theory with equal weights to different parts of the test. It doesn't matter, like you see here, it doesn't really matter. But this is going to be our preferred specification. This is what's interesting here. So, just like I said here, on average, girls are about 0.14 standard deviations below boys. But amongst children of university-educated mothers, there is no difference in the performance of girls and boys. This is the interaction, 0.14 standard deviations. This is the main effect for girls. So in households in which mothers have university education, there is actually no difference in the test performance in math of boys and girls. Given that maternal university education is not randomly assigned, I don't want to go out there and say this is absolutely a causal effect, but there is something here, and in fact, I don't have the tables here, if you see, if I can manage to forward, when we control, and I can send everybody the paper, when we control for wealth, it's exactly the same. So it's not a general wealth effect. It's not that, in households where mothers are more educated, girls do as well as boys because those households are richer. Because when I control for wealth, or when I do it comparing households of high and low wealth, I don't find this protective effect. The protective effect, I don't find it either for father's education. I find it only for mother's education. So again, it's not randomly assigned, but boy, it sure looks like there's something to mother's education because it ain't wealth and it ain't father's education. And moreover, if I separate the sample into households that are headed by single mothers and those that are headed by mothers and fathers, where both parents of the child are there, we find the effects are really large. The protective effects of maternal university education are really large in single-headed mother households. In fact, in these single-headed mother households, girls perform better than boys. No, that's not true. Girls of university-educated mothers perform better than boys of university-educated mothers in these single households. Okay? So the overall conclusion of these the first part, the descriptive part of the paper, if you want, is that, the overall conclusion is that there is this girl disadvantage. The girl disadvantage is much larger in some parts of the test than in other parts of the test. The girl disadvantage is not there in households where the mother is university educated. That effect, I'm putting it in quotation marks because it's got to be very careful. That effect is not a wealth effect. It's not a fact about paternal education. It's just maternal education, and it is particularly large when mothers are on their own without the father of the child. So there are various possible explanations one could tell. One is that, for example, in these single-headed mother households, mothers don't have to bargain with fathers. Right? They can say, this is what we're going to do. Right? There are no fathers to bargain with, and in fact, whatever it is that they do in those households, these university-educated mothers end up with more education, higher test scores for girls than for boys, in fact. Now, a methodological point here, which may be of less interest in this room, but is sort of interest, if you want, in the more academic literature, is the following. Because, as I showed you before, I'm not going to go back with this, and it takes forever to come back, because that the gender gap is sensitive, the magnitude of the gender gap is sensitive to what questions are in the test. I showed that to you before. Remember the word problems versus visual spatial abilities. And because what you test in different grade changes, for the reasons that we said, I can't test kids in kindergarten on multiplication, you can pretty much show, a question that we all want to answer is like, okay, there's this gender gap. Is it growing? Is it increasing? Is it decreasing? Like, kids come in with a particular gender gap, and does it then increase? Does it decrease? It seems like an important question. But the point is, you can show almost anything, depending on what questions you include and how you weight them. So we are confident in the overall results, but we don't want to say anything about whether the gender gap is increasing or decreasing, because it is very sensitive to what questions you include and how you weight them. This is very similar. There's a recent paper by Bond and Lang, which looks at the black-white test score gap in the US. And their point is, some people say that the black-white test score gap, which is there, increases as children progress through the school system, or decreases as children progress through the school system. And what they show is, really, you can show anything you want. It's always there, but it's either increasing or decreasing or staying the same, and it's pretty much the same with ours. Okay. Now let me get to the second part of this. So this is the descriptive part. Now I'm actually going to make use of the random assignment. So basically, what I'm going to do is I'm going to calculate value added, basically, and this is really only just sort of these methodological points. What I'm going to calculate is essentially value added in a classroom separately for boys and girls. So that's how much on average in classroom A, which is the better classroom, in this example, in my head, how much did girls learn relative to the worst classroom, and how much did boys learn? Remember, this goes back to this question, some classrooms are better than others. Some teachers are better than others. Some people have said, look, boys are much more sensitive to the same level of input than girls. And some people have said, no, girls are more sensitive to the same level of input. We can test. We know that these kids were randomly assigned to either classroom A or classroom B. We know they were randomly assigned to teacher A, teacher B. We also, as I'll show you in a second, know whether they were assigned to better peers or worse peers. So we can test when a boy gets a better teacher, what is the effect on his learning? When a girl gets an equally better teacher, what is the effect on her learning? When a boy gets a better set of peers, what is the effect on his learning? When a girl gets a better set of peers, what is the effect on her learning? So all of this is basically that conceptual exercise. And so here's what we got. These are stacking for all grades. Here, these are the most interesting ones. Stacking for all grades, what you get, these are the classroom effects. So this is a one standard deviation increase in classroom quality. How much of an effect does it have on child learning outcomes if your child is a girl or it's a boy, and these are indistinguishable. So in our data, we find what I'm saying, the exercise here is, the question is is it that for the same level of inputs, in this case, classroom quality, is it that for the same level of inputs, girls benefit more than boys, or boys benefit more than girls? The answer is no. For the same level of inputs, they benefit the same. Not only are these numbers statistically indistinguishable, they are really, really close to each other. And we do a variety of other things to test different aspects of classroom and teacher quality. Remember, for kindergarten, we could calculate not only classroom effects, but teacher effects. You guys remember that from the beginning of the presentation? I said when you have two cohorts, you can actually see what part of the classroom effect is a teacher effect and what part is other stuff. So we can calculate teacher effects for kindergarten only, for boys and girls, indistinguishable one from the other. Girls and boys in kindergarten benefit equally from having a better or worse teacher. There's a literature which suggests that girls in particular benefit more from having a female teacher than boys. It may be that everybody benefits from having a female teacher, or it may be that no one benefits in particular from having a female teacher, or it may be that a female teacher benefits girls more than boys. Again, we are assigning these kids randomly to these classrooms. So some got a male teacher, some got a female teacher. We can only do this actually for third grade because in the earlier grades, almost all the teachers are women. But in the third grade, about 25% are men. So we can see, is it better to get a female teacher than a male teacher by random assignment? And the answer is, it's not. And not only is it not, it is not better for girls or for boys. The effects are minuscule. So for example, girls randomly assigned to have a female teacher have 0.001 standard deviation, lower test scores than girls randomly assigned to a male teacher. The point here is not the negative. The point is the 0.001. That is 0.1% of a standard deviation. I mean, it's nothing. So in our data, differently from what other people have found with non-experimental assignment, what we find here is female teachers are just as good as male teachers, or just as bad, or whatever you want to say, and they're equally good or bad for boys and for girls. So what is it that actually, I've got half an hour, and this is the last, and I'll definitely leave time for questions. What is it that actually makes a difference other than just saying, which I think I still stand by what I normally say, which is, look, there are big differences across classrooms and teachers, and virtually nothing that you observe about them explains these differences. So we should think hard about, when we think about policies, how we want to do things, because really saying this teacher is like this or like that, and this teacher is like this, like that, so this one's going to be a better teacher than this, doesn't seem to do very much. The only difference, the only thing that we found, even with extremely rich data, is some evidence that classroom interactions matter. Now, we have this instrument, we have, as I said to you, what did I say? I think 4,500 days of teachers teaching, or whatever the number is, some alarming number of classrooms filmed for a full day. I don't know how many of you know about the class. The class is an instrument that measures the quality of teacher-child interactions in three particular dimensions: classroom organization, socio-emotional support provided by the teacher to the children, and instructional support. And within that, there are very concrete things. So a highly trained video coder is watching the video, which is 20 minutes long. You cut the full day into 20-minute segments. And this person is watching this video and checking for particular behaviors. It's not like, yo, looks like there's good classroom organization here, and yo, looks like, there's a lot of social-emotional support. It's not like this. It's very highly coded. Okay? And on the basis of that, you get either these three separate scores or an aggregate score for the class. Turns out that these three are very highly correlated. So a teacher who's doing well on classroom organization overall is also doing well on social-emotional support and on instructional support. And it turns out, and I'm sure if you did it in some other developing country, you'd find very similar findings. The class goes from a 1, which is like no teacher ever does anything good in the classroom, to 7. Every minute the teacher is doing something spectacular in the classroom. So between 1 and 7, the average teacher in Ecuador is about 1 point below the average kindergarten teacher in the US. This is a big difference. It looks like it's only 1 point, but it's actually equivalent to about 2 standard deviations. Okay, so let's look at the class. So, every teacher has good and bad days, but some teachers have more bad days than good days, and some teachers have more good days than bad days. And I'm going to show you a couple of videos that show essentially what a good classroom as per the class looks like and what a bad classroom, a low-scoring class looks like. If you don't understand Spanish, you're not going to get all of it, but you're going to get sort of, I think, the general gist of what's going on. So, I don't know how to do this. Oh, no, that's not what I wanted to do. As you can see, technology is not my... I have to, some of you know how to do this? I need to click on this. Does somebody know how to do it? I just don't know how to...
Exactly.
Okay.
Right.
No,
Yeah, that's fine. Okay, this is a low-quality classroom. The teacher is teaching. She's standing at the front. All right, so not dismal in the sense that nobody's beating each other. There's none of the behaviors that were on that list of behaviors. They're not exhibiting it here. So this is not like we looked through 2,500 days of video and found the one. I mean, you can find anything you want in 2,000. Let me tell you, you can find anything you want. This is sort of an average low-quality classroom. What's going on? The teacher's standing in the front. She's writing something on the board. Most of the kids don't seem to be paying any attention. They're wandering around, doing whatever, talking to each other. It doesn't look like there's a lot of learning going on over here.
Do the teachers know that there are cameras?
So the teachers know that there are cameras, but what we found is that you would think that the teachers are sort of acting for the camera, that it would be most obvious sort of in the first hour, let's say. By hour 6 of the classroom day, I mean, it's really hard to act for a full day. Frankly, if you don't know how to handle a classroom, you probably don't even know it in hour 1. But what we find is that the class scores in hour 1 and 6 are indistinguishable. So even though we actually end up throwing away the first hour, but even though, that we throw it away, there's no reason to throw it away, because really the teachers are just doing, I think they have a hard enough time just doing their thing. And so just having a camera planted in the back of them, just sort of, it's not like the cameraman is going like, hey, everybody, hey, over here. Nothing like that. It's just sort of panning around the classroom, what's going on. Okay, so now let's look at a high-quality classroom. This time I think that even I can figure it out. Possibly.
El compañero me dice animales salvajes, animales domésticos, el león. ¿Qué dicen ustedes? Brian dice que animales domésticos, el león. ¿Qué dicen ustedes? ¿Qué clase de animal es? El león es un animal. ¿Y por qué es animal salvaje el león? Porque anda en la selva. Es un animal feroz y muy grande.
All right. First of all, you can see that most kids are listening. They're sort of, these are little kids. You can't expect them all to be like, yeah, let me take notes here. All right, they're little kids. Mainly they're listening. The teacher is explaining something, is taking feedback from the students. So for those of you who don't speak Spanish, is a lion a wild animal or a domestic animal? So the first kid said a lion is a domestic animal. And then she said, who agrees that the lion is a domestic animal? No, it's a wild animal. Okay, everybody, put up your hand. Who wants to talk to that? Oh, it's a domestic. Why is it a domestic animal? I don't know. I forget now what exactly they said. It's a domestic animal because he's fierce and large. And then she said, that's right. It's a domestic animal. It's a wild animal because so there's a give and take. There's a routine in which the kids are paying attention. The teacher is paying attention to the kids. She's not just just up there writing whatever she wants to write, and she's actually checking in with the kids about what they're understanding, what they're not understanding. So this is a high quality class setting. Okay, so what about the effects of the class? Before I look at this here, if you look at enough of these videos, it'll become apparent that it is, even with very highly trained coders, and even though they are systematically, some teachers are better than other teachers, You know, if you take any particular 20-second or even 20-minute snippet of what's going on in a classroom, it's not going to be representative overall of what goes on in a classroom for a whole school year, which is at the end what you're trying to relate, how you're trying to relate it to learning outcomes, right? So you might get a very bad teacher in a very good, on a very good day or in a very good moment in that 20-minute segment, and so then they look like they're very good, and you might equally get a very good teacher who's just having a really crummy day, and they might actually look quite bad. What does this mean? It means that when you're regressing, at the end, this is the exercise you're trying to do. You're saying, what is the effect of the class on learning outcomes? What you got on the right-hand side is the class as measured from that, not the true behaviors that over a whole year teacher A and B do, but what you see in a 20-minute segment for teacher A and teacher B. But for the first year, for kindergarten, we actually have the class with this cohort of kids, as well as the class with a cohort of kids they had in an earlier year. So what that allows you to do, and I'm not going to get too much into the nerdy stuff, it allows you to instrument this year's class for the teacher with last year's class. And what that does, and we don't know about the econometrics of it after, it essentially rids the class of measurement error. Now, why do I mention all of this? When you do that, when you just throw in the class as you measure it, the overall effect that you get, the association between the effect of the class on child learning outcomes is about 0.04 standard deviations. So a teacher that has a 1 standard deviation better class score, her students learn about 4% of a standard deviation more. But when you clean out the measurement error out of this becomes almost 3 times the size. This becomes about 0.12 standard deviations. I'm mentioning this not just because, you can, it's so clever econometrically, but because it means that really, when you're looking, it depends whether what you want to know is how well does looking at a teacher for 20 minutes allow me to distinguish whether she's good or bad, that's this number, or how much does it matter whether a teacher is doing these things that are measured in the class, how much does that matter for learning outcomes? That's not the right number. The right number is that without the measurement error, and that's about 0.12. Okay? In any event, various important findings here. First is that the class matters in kindergarten and first grade more than in second and third grade. So these things that the class is measuring seem to matter more amongst the youngest children and less amongst the somewhat older kids. And we can reject that these coefficients are the same for the 4 grades. So this is not just it looks like it's somewhat different, it is actually different. The second finding is that whatever it is that the teacher does in terms of the class matters the same for boys and for girls. So this part of the story is very consistent with everything we've seen before. There are better teachers. Some of it has to do with whatever they're doing in the classroom that we can measure by the class. Kids assigned to these teachers learn more, but boys and girls learn equally more when they're assigned to a better teacher. Last, I don't have to go through it, okay. So last thing, peers. Like I said, when you assign 37 kids to classroom A and classroom B, not only do you get different teachers, you get different peers. And the peer quality you can measure in various ways. But one way that has been measured a lot in the literature is what is the average baseline, so lagged, test score of my classmates? So do I have a bunch of really bright classmates or do I have a bunch of less bright classmates? Right? Because I got a random assignment and it just by chance happened that I got all the bright classmates here, all the bright kids over here, and all the not so bright kids over here. This is not a problem for the previous estimation because it's uncorrelated with anything else. It's uncorrelated with teacher quality. But nevertheless, you are going to get some imbalance. It's not very large. The average imbalance that you get is about 0.16 standard deviations. This is not an effect. I'm saying this is the average difference in your classmates' test scores between classroom A and classroom B. It's about 0.16 standard deviations. But if you look, in some cases, there'll be essentially no difference, 0 standard deviations. You just got perfectly balanced. And at the 90th percentile of the difference, you'll get classroom where it's almost a half standard deviation different. Baseline test scores. So the question we're going to ask is, if you got, by luck, by lottery, you got the really smart classmates, as in half a standard deviation smarter classmates, do you do better than if by lack of luck you got the much dumber classmates, dumber as measured by their baseline test scores, not by what happens in your classroom now, but how they were when they arrived. What you find is nothing. So it does not matter. This is the effect. So this is a 1 standard deviation increase in peer quality. How much does it affect your learning outcomes? By about 0.8% of a standard deviation. It's not only is it not significant, it is beyond minuscule. The only caveat I would say to this is that this is for this range of differences. Now, maybe if you got a whole bunch of peers who are 3 standard deviations smarter, maybe the peer effects would be large. We can't say because our variation is within a relatively limited band. But within that band of between like 0.1 to 0.45 standard deviations, whether you got the better kids or the worse kids as your classmates doesn't make any difference. It does make a difference, like I said before, whether you get this terrible kid who just disrupts everything all of the time. But this business, look, I'm a parent. Parents worry a lot. My God, what's going on? We got Johnny so-and-so. They don't know anything. My son isn't going to be able to learn because, we have to wait for these laggards who don't know how to add yet. My son is brilliant. He knows how to add and multiply. I mean, parents, I'm parodying, obviously. Parents worry. Those of you who are parents of young children probably worry about this too. Who did I get? I mean, this is crazy. I got these. Oh, I'm so lucky. This suggests, stop worrying. Stop worrying. At least in this setting, stop worrying. Right? And it's on the other hand, it's saying if you hear that there's this one kid who's just destroying school property, kicking everybody, trashing things every day, worry a lot. Because the teacher probably can't handle it. And the teacher is going to spend, you see it in the class videos too, the teacher is going to spend the bulk of her day just dealing with this kid. They're going to spend most of their energy not on teaching anything, but just figuring out, what on earth do I do with this person? Yes.
That's what I was going to ask.
Okay. Yeah. Okay. All right. It's because on average, the average don't make, but the really badly behaved kids make a big difference. Yep.
Because the kids were randomly assigned to the classes, no? So on average,
average, they are the same. On average, they are the same in classroom A and B, but they're very rarely perfectly balanced. If you had 10,000 kids in classroom A and 10,000 in B, they would be identical, right? But they're not identical because you only have 30. So right now, I close my eyes, I put all your names in a hat, and then I draw out the names of the number of people who are here. And I draw half here and half there. Maybe in this group and in this group, they're equally the same number of women. Maybe, but possibly not. Because if I do it for the whole bank, then yes, you'll have exactly the same number of men and women here by random assignment. But if I do it for this number of people, there will be some imbalance. The important thing for our estimation is that this imbalance is not correlated with, for example, teacher characteristics. So I can say teachers do blah, 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 and it's not the peer effects. Because the peer effects, you got the good teacher, you got the bad teacher. In some cases, the good teacher also got the good peers, and in some cases, the good teacher got the bad peers. They are orthogonal to each other. Peer and teacher, and everything else. There's imbalance, but it's orthogonal with the other things. That's what allows you to cleanly estimate the effect of peers versus teachers. Okay, last one. Yes, sorry. No?
Oh, just about that. I mean, with the peer effects, did you look at all at gender imbalance in the classes? Because I would imagine.
Yep, here we go.
Oh.
Exactly. This is exactly the last result, and then I wrap it up. Literally, it's the last result. So here, what we have is builds on the work of Caroline Hoxby, who argues exactly that. That girls in particular, everybody benefits from having more girls in their classroom relative to boys, and that girls in particular benefit from having more girl classmates than boys. And so, exactly, so we have some imbalance in the number of girls. It's not huge, so you got 36 kids. On average, the difference in the number of boys and girls is 2, so it's not huge. What that means is that on average, there'll be 17 boys or girls in that classroom and 19 boys or girls in the other classroom. But you can have schools that are quite unbalanced, just like you did with the peer quality. And at the 19th percentile, what you have is 14 of one gender and 22 of the other gender.
So there was no only girls classroom?
No. And this is exactly an important point, because what I'm going to say here, what I show here, is that these are a little bit more noisy, but I hate this. These are a little bit more noisy, but basically it doesn't matter if you got more girls than boys. on average, because again, it is, I mean, think about these boys that are really troublesome. They're only 50 or 60, so they're not going to affect on average sort of. It's not going to be enough of them to actually show up when you're just looking at the average number of girls and the average number of boys. Neither girls nor boys benefit in this data set from having more girls or more boys in their classroom. Now, exactly what Keiko asked. The important is, this is again sort of like the other result I showed you before. This is for this level of boy-girl imbalance. Now, if you were to say, well, what about single-sex education? Well, I have nothing to say about that. I have nothing to say about that because my variation is this variation. Increase the number of girls a bit, or decrease the number of girls a bit, or maybe a fair amount, but I don't have anything to say about single-sex education where it's completely radically shifting the number of girls and boys in a classroom. These are not, there's nothing wrong with these. It just means they're not the right data to answer that question. Just like the previous data where I said, 0.5 standard deviations at the most is not the right data to answer the question, for example, about tracking. Do you want to track? Well, when you're tracking, you're probably sorting kids out, not by 0.25 standard deviations. You're probably saying the kids in this classroom and this classroom are 1.5 standard deviations different. And I have no view about whether that's good or bad. I mean, different papers show different things. My point is these data don't allow us to answer that. They do allow us to answer this, sort of these somewhat small differences in peer quality. And there's a large literature on this which claims to show, and presumably in some cases correctly, but claims to show that even these small differences have large effects on your own learning outcomes. This does not seem to be borne out here. Okay. So, just to wrap up, like I said, the most important thing that you should take away from this is a unique experiment. If you ever want to ask us how much the IDB has spent on this, well, you can ask, and I will tell you that it is over $10 million of IDB funds, not IDB owned, what at least in the bank in my time used to be called BB. $10 million of BB been spent on this. It was a strategic decision made by senior management at the IDB to invest in some very high-level research projects. This happens to be one of them. So this is why we will eventually have 7 years, following these kids for 7 years with these very rich data, which allows us, I mean, I've just shown you a sort of sprinkling of something which will allow us to answer many questions, we think and hope. We have very rich data, obviously, and it's very well suited, we would argue, and certainly that's what people tell us when we presented it also at academic conferences. It's very well suited to answer really fundamental questions about how human capital at young ages accumulates, about the role of peers, households, teachers, and so on, how all of these things interact, how they accumulate over time in a way that just hasn't been possible before. These are some of the effects, like I said. There are these classroom effects. They are substantial. They are substantial in the sense, like I said. I mean, in fact, the magnitude, here's one way to think about the magnitude. If you go back to think about those bars that I had for socioeconomic status and math learning outcomes, the difference between a child whose mother has university education and a child whose mother has only elementary school education is about 0.5 standard deviations. That is the same difference as being randomly assigned to 4 good teachers. Good teachers, again, not the 95th percentile of teachers, just the slightly above average teacher. Get 4 of those in a row. It's as if you took a child whose mother has primary school education and turned him into a child, or her, into a child whose mother has university education. And in fact, even those numbers understate the magnitude of the classroom and teacher effect, because everything is being driven off the within-school variation in classroom quality. I did not randomly assign Halsey to this school and Keiko to that school. Right? I assigned Halsey to teacher A and Keiko to teacher B in this school. Now, overall, in that school, teachers are better than in this school. So if I were to take account, now, I can't cleanly identify the effect of that because there's no random assignment across schools. Our best estimate is that probably you should take these numbers and multiply them by about 1.5 if you wanted to take account of the fact that there's actually a substantial amount of variation in teacher quality across schools. So if you were to do that, now we're talking of 0.75 standard deviations from having 4 good teachers in a row. Good, again, just above average teachers. These are very large numbers compared to almost anything, compared to socioeconomic differences, compared to differences across countries. These are very large differences in the learning outcomes of children who just happen to get a somewhat better sequence of teachers than other identical on average children. In terms of math, what I said is girls lag behind in math achievement relative to boys, much more in some math tests than others. As I said before, if you wanted to say something on how this evolves, you'd be hard-pressed to find something that is very stable. Maternal university education is protective of the math achievement of girls relative to boys. These effects are suggestive, as I said, for the reasons, but these are not driven by the random assignment. And girls and boys respond similar to the quality of classrooms, teachers, and peers. And with that, thank you very much. I didn't leave much time for questions.
Very, very impressive. I have questions, but let me open up first.
Yes.
Can you explain a little? I asked this question earlier about good teachers and bad teachers, and value added was the main parameter. But was that benchmarking limited to a particular school or the whole population of teachers? I'm just trying to think if there were schools that didn't have any bad teachers or schools that had only good teachers.
You're exactly right, and that's the point that I made at the end.
Yeah.
What we do, and this is why our results understate the real effect of teachers, because what we do is we say, we are going to define within a particular grade and school. In almost all cases, in that grade and school, there are 2 teachers. Some cases there are 3, 4, 5. But let's just stick to the example where there are 2. And I'm going to say, the good teacher is that teacher whose students, on average, conditioning on how much they knew when they came in, how much do they know at the end of the year? That's value added. And then I'm going to say, in this classroom, there was more learning than in that classroom. So I'm going to say this is the good classroom, and this is the quote-unquote bad classroom. But you are right that there are going to be cases in which the difference between the good and bad are very small. And also, those differences do not take account of the fact that there are going to be these large, this is my last point that I made before, these large differences across schools. That if you took into account those large differences across schools, these results would be substantially larger. Because all we're doing, we're saying, look, and we can't do that, look across schools in a random, it doesn't exploit the random assignment. Because then it might be, oh, this school is better than that, but maybe it's because parents in that school care more about this and that, so it's not really a teacher effect anymore. That's why these comparisons across schools are non-experimental. Like 99% of the literature on this. But because we have such clean data for the within-school comparisons, we're primarily making these within-school comparisons. But if we were to make the within and cross-school comparisons, the effect of having a sequence of good teachers would undoubtedly be better, and our best guess is that you should take all these numbers and just multiply them by 1.5. Yes?
So one takeaway I have is that better kindergarten
Yes.
teachers have a larger effect on student learning.
Yes.
But in policy, they normally attract, kindergarten teachers are normally not the most well paid and
I agree.
well educated. So with this conclusion, can we now perhaps introduce this concept to policymakers and say, think of ways to attract better kindergarten and lower grade teachers?
Absolutely. Use my graph. No, that's exactly right. You're exactly right. What we find is that, again, defined in this way, whether you got the more learning teacher or less learning teacher in kindergarten is about the difference between the higher learning and lower learning teacher on outcomes in kindergarten is about twice that as in 3rd grade. So one has to be a little careful, and I don't want to confuse everybody. Strictly speaking, what we're saying is, if you could take these crummy kindergarten teachers and make them crummy, the kindergarten teachers who are the less good ones, and turn them into the good ones, relative to taking the less good 3rd grade teachers and turning them into good 3rd grade teachers, if you did this and this, the effect of doing this, your kindergarten teachers, is twice as large as the effect of doing this. Now, there are two possible interpretations underlying that. One is that there's a big difference in kindergarten teacher quality. You've got some that are really, truly outstanding, and some that are really, truly terrible. So flipping these into this makes a bigger difference than in third grade, where they're all sort of more tightly packed. That's one interpretation. The other interpretation is, look, just whatever teachers do matters more in kindergarten, so we should worry about kindergarten more about the later years. These things you can't sort out which of the two, but the policy implication, to my mind, is still very similar in that if you were, at least part of the policy implication, if you were able to turn some of these not so good kindergarten teachers into good kindergarten teachers, you'd have a very big impact. A lot bigger impact than if you were able to turn the not so good third grade teachers into good third grade teachers.
But on this kindergarten point,
yes,
were they teaching like math?
No, they were doing. You saw it. They're doing.
That was kindergarten.
That, I think it was either kindergarten or first grade. It looks like that.
Yeah.
That was first grade. That was first grade. Kindergarten looks pretty much the same. They're not teaching math. They're teaching. Look, this is. My kids go to some fancy private school here, and you worry about. No, this is not. I don't mean to belittle anything. This is not a setting like I don't know, Central African Republic, where you got 90 kids in a classroom and no teaching material. This is somewhere in between, right? But they're teaching largely by rote, right? They're standing up front, and the kids are doing whatever they're teaching. But the better teachers are doing, like you saw on the class video, they're sort of bringing out the students, saying, "Okay, is this a number one? Yes, it's a number one. Is this a number? Which number is it? Here are two piles. In this pile, how many are there? In this pile, how many are there? What is the difference in the number?" It's this kind of stuff. But in one case, they're doing that, and largely kids are paying attention, interacting, listening, whatever. And in another case, it's like the other classroom. Like nobody's paying any attention. Kids are just wandering around most of the day. The teacher is doing whatever. Sometimes she's sitting at her desk for an hour and a half. Sometimes, as with the results here for the World Bank, sometimes they're not even in the classroom. This is all conditional on teachers being in the classroom. So this is, again, it's sort of understating. The class is understating sort of real difference because saying you can only film the teachers who are in the classroom. So if you happen to get the teacher who never shows up relative to the one who shows up, well, clearly you're a lot better off in general with the one who shows up. This is saying, in addition to that, two teachers who show up, the one who shows up, who does certain things, is a better teacher than the one who doesn't show up. Yes.
So I have a question. Did you look at the class score, for example, in the within average difference in kindergarten and first grade, second grade, to try to see whether, at least at that measure of quality, is very different within kindergarten and within first grade?
That's an excellent question. And the answer is, we did look at it, and that's actually, if you look at the graph I had of the distribution of the class in the US and Ecuador, you can do that exact same graph looking at the within, that was not the within school, that was just the average class score of kindergarten teachers, first, second, third. So on average, they are no different, kindergarten, first, second, and third. The lines are almost exactly, but if you do the within school difference in the class scored in kindergarten, first, second, and third, they're very similar. So that's an excellent point, because what that is saying is in order to answer your question back there, if we had found that in kindergarten the class score were very dispersed, and in third grade it was very tight, then you'd say, okay, yes, turning these crummy teachers in kindergarten into good teachers in kindergarten has a bigger impact than in third grade, and it is primarily because the crummy kindergarten teachers are really crummy, whereas the crummy third grade teachers are not as crummy. But we don't find that. We find that at least by this measure, the class, the difference between the better and worse teacher in a school in kindergarten is very similar to the difference between the better and worse teacher in a school in third grade. So that suggests that it really isn't about, kindergarten teachers is more dispersed. What it suggests is rather than actually whether you got the good or the bad teacher, sort of holding fixed sort of the amount of the difference actually has a much bigger effect in kindergarten than in third grade, twice as large. This is not kindergarten versus 10th grade. We're talking kindergarten versus third grade. And I should say, I know I'm running out of time, but I just wanted to answer because there are extensions. If you look at how the effects depreciate, you find So that's a whole other one. Maybe I won't talk about depreciation. If somebody was interested in depreciation, I'm happy. The bottom line is depreciation is very similar for kindergarten, first, second, and third. So you've got these big differences in the contemporaneous effect. What I showed you is at the end of kindergarten, whether I got the better or worse kindergarten teacher, how much did I learn? At the end of first grade, whether I got the better or first grade teacher, how much did I learn? At the end of second grade. But you can also say at the end of second grade, at the end of third grade, how much does it matter whether I got the better kindergarten, the better first, the better second grade teacher? And obviously, the effect in general decays. It decays because the contemporaneous effect is larger than the lagged effect. It sort of depreciates, okay? But the depreciation is no bigger in kindergarten where it starts up like this, it goes down to this. And in first grade or in third grade where it starts like this, it goes down, by the same amount. Okay, maybe that was confusing, but I'm happy to talk more about it. A general finding in the literature is that the magnitude of classroom effect, if I have a good teacher, then at the end of my grade, where I had that good teacher, I know a lot more. The question is, 3 grades later, do I still know a lot more than the poor sod who got the worst teacher? And the answer is yes, but less of a difference than at the end of the grade when I got the good teacher, which kind of makes sense. Okay.
Just
yes.
Going back to the original topic of gender gap.
Yes. There's so much interesting stuff, both on gender and on the other.
So if I understood correctly, teachers, the classroom, these badly behaved kids, or the mother's university education, they don't have different effect on.
That's right.
So what do you think explain that? Going back to your earlier point of that.
That's absolutely right. So in some sense, there seems to be something that happens in households. Okay, I want to be careful what I say. First thing I want to say is there does seem to be something in households that drives the gender gap. Why do we say that? Because in households in which mothers are highly educated, there is no gender gap. And even more, in households where mothers are highly educated and don't have to deal with some husband, girls actually do better than boys. This is about households. That part is about households, right? So something is going on about households. Now, there may be things going on in classrooms, and I want to be careful on what I say here, that happen in all classrooms that negatively impact girl learning outcomes. Now, for example, if teachers always call on boys and never call on girls, and if that has an effect on math learning outcomes, then what you'll find is, what the result of that would be that girls are behind boys. That's what I said, in part, because teachers call on boys and not on girls. Now, why can't I clean that out in my data? If that is something that all teachers do equally, then it's just in there. I can't say, there's no variation. This is conceivable. It is conceivable. And in fact, we could code the video. The video is so rich that we can see, do teachers who call more on boys than girls, is there a bigger learning gap in math in those classrooms than in classrooms where teachers call more on girls than on boys or call on them equally? We could do that. We haven't done that. All that we've shown so far is that if you got 2 classrooms, and in those 2 classrooms, what you have is you either get better peers, better teachers, whatever. So this classroom got better than this classroom got better than this in this dimension. None of that seems to drive the gender gap. So there's something about households and possibly other things about teachers that we're not measuring for the time being. Okay, other questions? I know I'm over time. But I've only seen one person walk out, so it must be that you're reasonably interested. It's okay. You won't offend me if you walk out. I'm not going to be like, yes.
No, you said to ask about executive functions.
Yeah. Oh, executive function. Executive function is fantastic. Executive function is so cool. The tests are so cool. I'm going to tell you one of the executive function tests that is my favorite. I'm going to tell you all the executive function tests. So executive function basically has 3 dimensions. One is memory, which is often lumped together with attention. So standard memory test is I read you a sequence of numbers, and you are asked to repeat that sequence of numbers. That's why it's often lumped together with attention, because you're just like spacing out. So it's hard to know whether it's memory or attention. And a harder task is I give you that sequence of numbers, and I ask you to hold it in your head and repeat it to me backwards. Okay? So Yeah, and you can see, sorry, I say to you 372, and you say 372, and then I say 372, and you're like 273. Now, this all sounds fine, but when you're 5 years old, it's not so easy, and the test is cumulative in the sense that at first you ask these lower, and some kids, it's so cool to see this test. You guys got to do this. You guys got to do it because it's so cool. I mean, you're out there, you get these little kids, like 79252, 79252, 3471189, 3741189. I mean, they're just, and then you got other kids who are just like 27. I mean, so that's attention and memory. Second one is inhibitory control, which is, I'm sure all of you, like all of us now, had some talk by Sendil Mulainatan or somebody else who shows you, you get a slide and it shows red and you're supposed to say, and it says a red ball and it reads on the top green or small, and actually even better, what you see is the word green written in red. And you're supposed to say red, not green, but they go quickly. So you're supposed to say red, which is the color in which it's written, but what is being written is green. So you have to inhibit your instinctive response, because if you read, of course, if you don't read, then it's the other way around. But if you read, the instinctive thing is to say what's written, but you're being asked, and if this goes quickly, it's actually quite hard. Now, what do you do with young kids? What you do with young kids is these tests are the same logic. So, for example, for the youngest kids, it's called the Stroop day and night test. In the Stroop day and night, you show the kid, look, I'm going to show you some slides. Some of a sun and some of a moon. Sun and bright day, and one of a moon with a night. When you see the slide that shows the moon, I want you to say day. And when you see the slide that shows the sun, I want you to say night. You practice it so they understand what they're supposed to do. And then the test basically involves flipping these slides quite quickly and seeing if the kid can inhibit her response. She wants to say day when she sees the sun, but she's supposed to say night. That's inhibitory control. Then you can say, what that on earth does it have to do with anything? But just give me 1 second and I'll tell you a little bit more about it. The coolest one to my mind is the third dimension of executive function is cognitive flexibility. And again, the test becomes harder as children age, but here's the one that you do for kindergarten and first grade. So there are two kinds of cards. There are cards that have little trucks on them, and there are cards that have little stars on them. And some of the trucks and stars are blue, and some of the trucks and stars are red. Okay? So then you tell it, look, Keiko, we're going to play the figures game. In the figures game, Keiko, all the trucks go in this little box. You see over here, there's a box. It's an open, like a little cigar box, and it shows the trucks, and all the stars go in this room. Right? Let's practice a little bit, Keiko. And then you say, this is a truck. Where does the truck go? Okay, truck goes with the trucks. This is a star. Where does the star go? And I say, okay, so you got it. Okay, now I'm going to show you a bunch of, and I'm just going to give them to you. And basically, 95% of the kids get them either all right or make one mistake because they just happen to space out. Everybody can do that. It's not a big surprise. Then you say, okay, Keiko, that was great. You did great. But now we're not going to play that game. We're going to play the colors game. In the colors game, all the red cards go in this box, and all the blue cards go in this box. All the red cards go in here, no matter if they're trucks or stars, and all the blue cards go in here, no matter if they're trucks or stars. So let's practice a little bit. Doesn't get it. Doesn't get it. Let's play the real game. Keiko, this is a red card. Where does it go? And she puts it not with the red cards, but she puts it depending on whether it's a star or a truck. So you say, this is a blue card, Keiko. Where does it go? If it's a star, she puts it with the stars, no matter what the color. After 3 mistakes, I stop her and say, Keiko, we're no longer playing the shapes game. We're actually playing the colors game. Remember that in the colors game, red cards go over here and blue cards go over here. This is a blue card. Where does it go? About a third of the kids cannot switch from the earlier rule. About a third of 5, 6, 7-year-olds cannot switch from the earlier rule. Some just make random mistakes. But about a third of the kids just no matter how many times you prompt them, are unable to switch from one rule to the other. I mean, it's just amazing. I mean, it's really interesting that this is how your little brain works. And what people have shown about executive function, these things actually predict just about anything you want them to predict. They predict your learning. So even in our data, just in an associational way, if I want to know what is your test score, your math test score in 3rd grade, and I control for your math test score in kindergarten and whatever else, all these other things, but I also throw in your executive function in kindergarten. So I'm throwing in executive function after controlling for whether your mother was educated, this, that, and the other, and your math, how much math you knew in kindergarten, and I throw in your executive function in kindergarten, the effects of executive function are large. So kids who are able to inhibit their response and say day when they see a moon and night when they see a sun, and kids who can repeat these numbers back and forth, and kids who can make the switch and so on, when you aggregate all of this together, you get an executive function score. Those kids do better in math, language, the kind of things that we quote-unquote worry about traditionally, right? Oh, do they know any math? Oh, do they know any language? The kids who know how to do these things do better on that, even if you control for how much math and language they knew. Which, of course, I mean, some of the math and language they knew then is likely because of the executive function they had before that. But I'm saying even if you control for that, executive function has a large effect on own learning outcomes later on. And it's certainly been found in long-term studies that executive function just affects just about everything.
Teachers affected?
And teachers have an effect. That's a really good question. This is actually really interesting. So not only do we find teacher effects on learning in math and language, which we do, those are the 0.11 standard deviations, roughly a 1 standard deviation increase in teacher quality results in about a 0.11, 0.12 standard deviation increase in learning in math and language. It's about a 0.07, 0.08 increase in executive function. So a good teacher, they're not teaching, this is also really cool. I mean, this is cool too, right? I mean, there's lots of cool things here, but this is really cool too. Because it's saying, look, the teachers are not teaching executive function, right? I mean, I'm not sitting there going, okay, I'm going to not do the curriculum. Everybody, here are the trucks, here are the stars. Let's play until kingdom come about these stars. They've never taught this. But in some classrooms, controlling for their lagged executive function scores, kids get more of this than in other classrooms, presumably because executive function is in part a function of these things that go on in the classroom, even though you're not teaching these things. So in a classroom where everybody's wild and throwing stuff at each other and in a classroom where kids are being use their mind to process certain things, they get better not only at processing those things, they get better at these executive function skills. That is cool. That is cool. I mean, teachers affect not only the things that you think they would affect, they actually affect executive function as well. All right.
Jose, you have a question?
Many questions. I'll talk to him later.
Okay.
This is great.
Thank you very much.
Thank you. Yes, we're in the last year. I should never check the number of pilots that are being